Okay, in this lecture we're going to start talking about quadratic functions. Quadratic functions are part of a function group called polynomials. And polynomials are functions that have the form f of x equals, right, and it has a certain size exponent, let's call it n, as the highest exponent, and of course quadratic functions will have a 2. The an there, subscript here, is just telling us this is the number in front of the x that has n, the exponent of n. And of course we just put it so that we decrease right all the way down to the final one, a constant here, which of course has an exponent of 0. Right, so a general quadratic, of course, we know has this form. Now, it just so happens that this would be the a2 term, this would be the a1 term, and this would be the a0 term. And the reason we use these subscripts is because what if we have a higher degree than 26, then we're out of letters to use. So if we use this subscript, this allows us to use very high order polynomials. This is what's called a degree 2 polynomial. All right, a cubic is a degree 3 polynomial and so forth. So n here is the degree. The highest exponent is the degree. All right, now what we want to do here, of course, remembering here that a can't be equal to 0, or we wouldn't have a quadratic, we'd have a linear function. So a linear function is actually a degree 1 polynomial. Now the reason we like polynomials is that they are easy to work with. So this is the degree, and so this term here is actually what's called the leading term. So that's the leading term, and this is the leading coefficient. It's the number in front of the leading term. So that's the leading coefficient. All right, now f of x equals 0 is a 0 degree polynomial, so it's what we call a 0 polynomial. Right, so of course the other thing that we need to keep in mind here is that all these numbers in front, which we call coefficients, right, these are coefficients. These are real numbers. Now, we can't have any thing but an integer, so in other words, exponents are integers, and not only that, they are non-negative integers. Right, so we can't have any half powers or fractional powers or negative powers or exponents. Right, so our first thing that you must be able to do is identify them, okay? So for example, f of x equals the square root of x plus 4x plus 1 is not a polynomial. Why? Because this is x to the half, and that's an exponent, that's not an integer number. Right, now the simplest quadratic, now remember a quadratic is really a degree 2 polynomial. Our simplest one was the squaring function. And you remember our squaring function, we could actually draw a table of values here. And x, and here's our x squared, so we could have negative 2, we would get 4. So if you look up here, negative 2, all right, we would have got 4, which is right, actually up here, right there. If I can find 2, 1, 2, 3, 4, so here's 2, and notice here's our 0.4. All right, so that's negative 2, 4, and when we had negative 1, we had 1, which is right there. And when we had 0, we had 0. And when we had 1, we had 1. So we had over here. and it was symmetrical, remember, around the y-axis. 2 we had 4, and that was up here. Right, so we had symmetry around the y-axis, so we had y-axis symmetry. Right, it is an even function. Right, the domain, right, was all real numbers. And the range, however, was from 0 to infinity. Right, it's decreasing, all right, from negative infinity to 0. And you can see that it's increasing from 0 to infinity. Right, so we have all of these things, all right, that we know about the squaring function. Okay, now the other thing is it's opening up. All right, if we had a negative x squared, it would open down. And notice there we have here now what's called a minimum point, and this occurs at what's called the vertex, right here, which is 0, 0. Right, and the parabolic shape is a typical shape for a quadratic function. So our first task will be to actually draw some quadratic functions, and we're going to do that by doing a table of values and getting enough points. So here we'll use x, and here will be f of x, and here our f of x function is given by this. All right, and so we should start plotting a few points. All right, to actually see what happens with this particular function. Right, now we already know from working with translations of functions that one is going to be upside down because of the negative sign. It's going to be stretched because of the 2. It's going to be moved to the left 3 units because it's got a plus 3 here, and it's going to be raised up 5 units in the vertical direction because of this 5 here. Right, now if we go ahead and we draw a few points, let's have a look and see if we can put some points in here. Let's go -5, for example. What happens to -5? When I put -5 in here, I end up with -2 squared is 4. 4 by 2 is 8, but a -8 plus 5 will give me a -3. So I'll need a -5, -3. So that's down here. 1, 2, 3. Right there. Let's try something like -3. What happens if I put -3 here? Well, I get 0 here, and I get a plus 5, so I end up with this point here. All right, well, let's try, what about a -4 then? Let's see what happens here. So -4 would give me a -1, squared is 1, -2 plus 5 would give me 3. So that would be right here. Well, we need to go to the other side now. We do know we have some symmetry with this, so let's try -2. Put -2 in here, and I get 1, squared is 1, times 2 is 2, -2, so they give me a 3 as well. What happens if I put a -1 in here? A -1 will cause this to be a 2. 4s are 8. -8 plus 5 is -3. So I get -1, -3. Right there. And what about a 0? It's always a good one to use. So we have a 9, 18, oh, it's going to be way too large. 18, so it's going to be pretty large. So it'll be off my scale. So I can see here, though, that this is going to be my, oops. And this is my curve, f of x. Now notice that we have this point here, which is now the vertex. And the vertex at this point is in fact -3, 5, which is rather interesting because it's the opposite of this, and it's also this. Okay. Now we can see some other things here. What is the domain of this? Well, the domain is all the real numbers. And what is the range? Well, the range is anything from negative infinity, because it's going all the way down here, but it peaks out right here at 5. And that will be our range. Right, now the other thing you'll notice is that we do have it narrower, which is what we expect from the 2. We do have it opening down, and that of course is because of the negative. We do have it moved negative 3 to the left, or 3 to the left, right, because of this number here, and then we have it raised up. Right, now that's an interesting concept, because that allows us then to think about a quadratic as having a general form like this, with an a in front of an x minus, let's use a h here, squared, plus a k. This is what's called vertex form, right, for a quadratic. And that's going to become very useful, all right, as we go to plot these kinds of curves, which of course are quadratics. Okay, so if you look at this here, if we can get it in this form, then it's going to be much easier to draw, because straight away notice that we also have symmetry around this particular line, which is going through the vertex. This is called the axis, and we can see that its x is equal to negative 3 because it goes through the vertex here. So we also have an axis, and then we can plot points either side of the axis because of the symmetry. Well, what if it's not in that form? Well, let's have a look at this second example. Again, what we're going to do is we're going to pick off some points. All right, and let's have a look at some points here, and we'll get a feel of how this is going to work. So what if I put in a negative 2, for example. If I put negative 2 in here, I get 4. Minus 4 is 0, and then I'd have I'd have a negative 8. Okay, so I have a negative 2, negative 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we get this point here. What about a negative 1? Well, if I put a negative 1 in here, what's going to happen? I'm going to have a 1 minus 5. So that'll be 1, sorry, and we'd have a minus 4 here. So that would be minus 3. Minus 4 would be minus 7. So that would be right here. Okay. All right, so we have, what about 0? Well, 0 would be, in fact, negative 4. 2, 3, 4, so it would be here. All right, so we're starting to get a picture. What about when it's 1? 1, and when it's 5, minus 4 would be negative 1. Right here. What about when it's 2? I'd have 4, and 8 would be 12, minus 4 would be 8. Alright, so I'd have 1, negative 1, and 2, 8. Right, now it may be better to go towards the negative now. What about negative 3? Well, negative 3 squared is 9. Minus 12 would be negative 3. Subtract 4 would be negative 7. So that's interesting. Alright, so here it is. Alright, next, what about negative 4? I'd have negative 4 would be 16. Minus 16, 0, and I have a negative 4, so that would be here. Right, so we're beginning to see now that this looks like it's going to be the axis. Which will be x is equal to negative 2. The vertex here looks like it's going to be negative 2, negative 8. Okay, and so what we need to do is it was 1, 2, 3 here, so it's 1, 2, 3 here. And so we're now starting to get a picture here. Oops, a bit rough. But of course this comes across 1, 2, 3, 4, goes to here, so we're going up here, like so. And so this is going to be our function. Now notice here this is the vertex. Alright, here's the axis. Alright, and it would seem that this is the function that's moved to the left 2 and dropped down to 8 units. Now why is that the case? Well, here's the reason. You'll notice that if I have x squared plus 4x minus 4, what if I was to complete the square on this? Remember, completing the square would mean half of this, which is 2, square it would be 4, but I can't add 4 without subtracting 4, and of course I've still got the subtracting 4 here. So this would be now my function. And so this part here is my squared part. And notice that I have subtract 8 here. So my function could be written as x plus 2 all squared subtract 8. And notice that this gives us the vertex of -2, -8. Right, now what is the domain of this function? Well, again, the domain, of course, is -∞ to infinity for a quadratic. And what is the range going to be? Well, the range goes from -8, -8 to infinity. All right, and that tells us that. And we have an axis here of -2, which of course is the opposite of this +2 in here. And this is the y for the vertex. A couple other things here. For this one here, of course, we have a maximum. And we have a maximum value of the function at x equals -3 of 5. Whereas here, we have a minimum of the function at x equals -2 of -8. Okay, right, so there's some basic quadratics. Now the key is here, can we get it into this vertex form? That will of course be our objective, and our technique for doing that, of course, if it's not already in that form, is to complete the square. And this is one of the reasons why we did completing the square, because we can now use it to help us draw these quadratic functions.